right. Well, I appreciate everybody being here. I know that this has been it's the last day of the conference, and so excited to kind of wrap it up. We have a busy panel. We have a number of different people that are going to be speaking today, but this is a complex issue, and I'm excited to have the panelists that we do have as well. And so for that, we're going to be talking about, this panel is protecting public health through water quality monitoring and management. We have two panels that are coming in because we want to make sure that we provide different perspectives and talking about some of the issues that we're facing here in Nebraska, but also globally as well, and how hopefully some of the issues that we're facing here, we can learn from other people and also share the knowledge that we have. And so with that, I would like to call out our first panelists, and I'll make a brief introduction of each of these individuals. We're going to have short presentations and followed by a moderated session. So Dan Snow, who, let's see, they don't come in order on this thing. So Dan is a research professor and laboratory director for the Nebraska Water Center here at the University of Nebraska-Lincoln. Rena Jones is a senior investigator at the National Cancer Institute. Nirupam Aik is the Richard L. McNeil Associate Professor of Engineering at the University of Nebraska-Lincoln. Andrea, where is Andrea on here? Andrea Bash is the Associate Professor of the University of Nebraska-Lincoln. And then Aaron Day is Associate Professor of Vadose Zone Science at the University of Nebraska-Lincoln. And so with that, I would love to call up Dan Snow as our first speaker and look forward to his presentation. And I'll just kind of pull over here.
Is this the...
Yep, the green button.
Great. Well, good morning, everyone. Thank you for being here for our panel on protecting public health through water quality management and monitoring. As Jesse mentioned, I'm the director of the Water Sciences Laboratory, part of the Nebraska Water Center and Dougherty Water for Food Global Institute. I'm also a faculty member in the School of Natural Resources. I've spent most of my career in Nebraska. Came here in '86 to do a PhD and started a family and just haven't left. It's a great place. So I was really excited when I was asked to talk about public health through water quality management and monitoring. There we go. And I just thought of a few points that I wanted to bring up as we start this session. Pretty high-level stuff. That's my occupation is to do measurements, and I do lots of measurements for research projects and other monitoring projects. So I understand kind of the process that's involved in making measurements for water quality monitoring. It requires accurate, reliable, and innovative measurements. Those measurement methods change over time, so we start to learn things about water quality because of improvements in technology. We have to compare those measurements to meaningful quality standards. And those quality standards have changed over time. I think that sometimes that trips up the public because we're saying this amount is safe and this amount is not safe. And as we get more information, we kind of change those values. It's hard to understand why we do that. On the other hand, water quality management requires managing pollutant releases and movement in the environment. It requires protecting or predicting water use and the consequences of water use. And again, it requires advancing our knowledge. And this example on this slide is one that I use sometimes in the classes that I teach on water quality. I'm not related to John Snow, at least not to my knowledge, but he is one of my heroes in water quality. He was a physician in the city of London back in the 1800s. And he was treating cases of cholera during a cholera epidemic. And this photograph shows the Broad Street pump that came to be known in symbolizing the science of epidemiology. If you're not familiar with the story, he was trying to figure out what was causing people to get sick with cholera. And there were lots of theories that were happening at the time, contradictory theories. Actually, the thought that water might be impacting human health was really a new concept, as was the transmission of germs or diseases between people. And either he or one of his assistants had mapped the cases of cholera in downtown London, and they noticed that there was a hot spot for cholera cases, and it happened to be very near a pump, the Broad Street pump, that was used for drinking water in that area. So it took a lot of effort and time to actually show that this was what was causing the cholera epidemic. Is actually pretty controversial at the time. But we now look at this mapping as being pretty innovative, a way to look at human disease and relate it to the use of that water and connecting it with human health. So I think Crystal Powers showed this in one of her slides or one of her presentations previously, and she mentioned that this is a great hydrologic cycle illustration that's put out by the U.S. Geological Survey because it shows how important groundwater is. And I agree. I think it shows how much we depend on groundwater and how it is connected with surface water, particularly in the Great Plains. And if we blow that up and look at just a portion of that hydrologic cycle, we can sort of see the state of Nebraska from west to east. We go up into the mountains. We have reservoirs draining into the state. We have canals that are using some of that water for crop production. And then as we go further downstream, we have grazing, agricultural water use, maybe pumping some groundwater. We're monitoring soil moisture. We have industrial water use. All of those uses are actually impacting water quality. And then when we look at the specific uses, things like water quality for aquatic habitat, there might be some issues in the water that is draining into a reservoir. We might have some domestic wells that are pumping water that contains some chemicals that could be impacting human health. We might have microbial contaminants that are impacting human health, as it did in London. We have public water systems that are using that same water, and sometimes they're drawing surface water, and some places they're drawing groundwater, the same groundwater that's being impacted by our agricultural water use. And then if we overlay on one more time that the types of contaminants that might originate from the processes affecting groundwater and surface water, areas of recharge, we have geogenic contaminants, things like arsenic and uranium, that might be carried into our water supplies through continued use of water. We might have some fertilizer and pesticides in areas where we're overusing agrochemicals. We have biosolids and industrial chemicals near areas where we have industries that need to dispose of or manage those contaminant sources. And then even in municipalities where we're disinfecting to remove pathogens, we might be generating some disinfection byproducts that affect or that could affect human health. So this is my summary slide. I think understanding water quality and public health requires engaging all of the water users in the scientific process, using innovative data collection methods similar to what Dr. Snow used in the City of London. We need to really do a better job of investigating how water quality has changed over time and relate that to what we know about chemistry, both in groundwater and at the surface. And then perhaps using some innovative programs, we can establish some new communication pathways with those communities and individuals who manage and use water. This photo is from one of our Know Your Well domestic well water sampling teams. I think it's the city of Taylor, Nebraska. They are our future water scientists and engineers. They could be decision makers I'm particularly excited about this program because adults that are listening to these students in their communities are starting to pay more attention to the quality of water in their communities and in their regions. And they might be influencing decisions about how to better manage water through this particular program. So with that, I'll turn it over to the next speaker.
And our next speaker is Rena Jones.
Great. Thanks so much. I'm happy to be here, and I really appreciated the John Snow example as an epidemiologist. He's considered the father of epidemiology, so it's a great segue to what I'm going to talk about. So what I want to give you a flavor for are the established health effects of a number of very common drinking water contaminants. This is not the universe of health outcomes. It's not the universe of contaminants, but to kind of give you a sense of what we know. So nitrate in drinking water has been tied to blue baby syndrome. I'm sure everyone's aware of that. It's the reason for regulating nitrate in drinking water now for decades. Nitrate ingestion from drinking water has also been associated with thyroid disease, a number of birth defects like neural tube defects, a reduced risk of cardiovascular disease, which kind of poses a dilemma in some respects, and cancer risk. Arsenic has been tied to skin conditions, a number of different cancers. DBPs, which were just mentioned, are tied to reproductive and developmental toxicity, respiratory disease, and cancer. And PFAS literature has been emerging in the last couple of decades, but they, as a class, have also been tied to reproductive and developmental outcomes, perturbations of the immune system, normal hormone function, specifically liver and thyroid function, and also a newly emerging evidence for cancer. So that's sort of the theme across these contaminants. In my research, I'm focused on cancer as an outcome, and I want to talk about the associations with nitrate specifically, because nitrate itself is not a carcinogen. But when we ingest nitrate from drinking water or diet, there's an endogenous transformation into N-nitrosyl compounds, which are very potent animal carcinogens in every tumor system or every organ system in the body. So some of the other contaminants are tied to one or two cancers in the literature. There's growing evidence that nitrate pretty much causes cancer at any organ site. And so I thought it would be helpful to kind of summarize what we know about nitrate and cancer in adults. There are some studies of childhood cancer, but they're very few in number. And so are the studies of cancer in adults. So we're not talking thousands or even hundreds of studies, we're talking a couple dozen. And I want to give you a flavor for sort of this fairly mixed literature based on a very small number of studies. So what we're seeing emerging is generally a positive relationship with nitrate in drinking water and colorectal cancers, specifically colon cancer, as well as kidney cancer and ovarian cancer. But you can see that the number of studies is very small. And of course, these are observational design. And somehow I left the primary site off the slide, which is gastric cancer and esophageal cancer. That's where that transformation into the carcinogens is happening, and the signal for that site is also very positive. But there's a few things to note about these studies. In almost all of them, we've seen the relationship at levels of exposure below the regulatory limit for nitrate. And that might make sense because that limit was not set based on cancer risk. It was set based on the risk of blue baby syndrome. Sometimes we only see the relationships in a group of people we would consider to be high risk. So they're ingesting a lot of, say, red meat, which sort of fuels that endogenous transformation into nitrosyl compounds. I mentioned that the numbers of studies are few, particularly for any given cancer site. So colorectal cancer, there have been 5 studies total. And populations on private well water are pretty understudied. So a number of these studies include people on private wells, but by and large, they're not included, and we know they likely have higher exposure levels. So that's a real gap in our understanding from the literature. So thinking about wanting to talk a little bit about the challenges of doing these observational studies of nitrate and other contaminants and cancer in particular, the challenge is really the exposure assessment. In cancer studies, we want to look over decades. We want to understand how much people took in over decades, many years. And we're typically reliant on the regulatory monitoring infrastructure for that, where you may have quarterly, annual measurements, et cetera, and again, lacking the data for private wells, so we're sort of left to model those. And we regularly or routinely don't know how much water people are taking in, particularly over long periods of time, which would influence the amount that they're exposed to. And then there are some implications, I think, on the regulatory side, the fact that we're seeing associations, not just for nitrate, but also DBPs, for instance, and arsenic at levels below the regulatory threshold. So, the idea is I think we need to continue to put forward more robust studies that are just sort of building that body of evidence. And I think the question is, at what point is the evidence sufficient to make a change in the MCL? And then lastly, I think, every drinking water talk I've ever given, someone in the audience says, would you drink the water here? And I think, the communities are concerned about these issues of contamination, right? And at least as public health practitioners, we have to balance what we know against community concerns, not wanting to raise undue alarm, but also just be very clear about what we know and the limits on the literature. So I think I gave you a flavor for how scant that literature is. And I think this is a point of conversation for the future. And that's it. I'm only in the red by 30 seconds.
Nirupam.
Thank you. So, go with this, or I'm trying to figure. Okay. So, I'm Nirupam Aich. I'm an associate professor in civil and environmental engineering. So, we go after this, or the green button? Yeah. Okay. Yeah. So we heard about PFAS a little bit. I will introduce that. Whoever don't know, there are a lot of different contaminants, nitrate, arsenic, but PFAS is one of the contaminant that we are looking at particularly, and Dan here also looked at PFAS. Those of you who don't know what PFAS is, PFAS stands for, I don't know if I have the full form here, PFAS, par and polyfluoroalkyl substances. So basically these are contaminants that are made from not contaminants that were made from, these are chemicals that were made from carbon and bonding carbon and fluorine together. So we use them in many different applications. These are highly heat resistant and water resistant. So we use them in non-sticky cooking pans. We use them in anything that needs water repellency, essentially, and heat resistance. So in firefighting foams, they have been used for decades, in carpets, in coffee cups. So they have been there. These are a class of like more than 10,000 to 15,000 chemicals that has carbon-fluorine bonds. And the reason we use them because carbon is more positive, fluorine is very highly electronegative, so they become very strongly bonded, which doesn't exist in nature. So natural processes don't really degrade these chemicals when they are out in the environment from our usage or manufacturing processes. So they have been coming to our drinking water, coming to our wastewater, and we don't really have the processes to take them out from our water yet. So they have been contaminating our water. And if we look at the amount of these chemicals in water, they are much less in concentration compared to nitrate. But even in that very small concentration, they can cause cancer and other diseases that has been found. And this is emerging, but we have a lot of like really important evidence with this. So what my lab does is look for ways to use nanotechnology, or what I would say like the technology that we use in cell phones, smartphones, computers, that electronic technology, and these small materials to develop new type of technologies like water treatment technologies, either to separate these chemicals from water, like adsorbing these chemicals from water, or to break that carbon-fluorine bond apart so that they don't become as toxic as they would be in terms of when they are bonded together. So, and EPA actually came out with the regulatory limit. It's very, very tiny, like 4 parts per trillion for 2 of the major PFAS compounds, PFOS and PFOA. And last year, April, and we were super excited about it. In one side, that we have to address this problem. The other side was that now we need to develop technologies for solving this problem. I don't know what will happen in the near future, because as of last week, EPA cut a lot of programs research grants for PFAS, understanding the PFAS contamination and treating PFAS, and they're taking a new initiative to discuss the scientific literature again. So that's where we are at this point. And so this is where the discussion is. Like, we have a drinking water limit, so it creates opportunities, but it also creates some problem because our drinking water or wastewater treatment technologies are not really at the level where we can take out PFAS. And we need to develop new technologies, and new technologies take time, it will take cost. So who is gonna pay for it? We don't know. Like, it's like $200 billion, more than $200 billion to $1 trillion cost. So we also don't know a lot of things about how we can address this for rural and smaller communities, because if you think about Lincoln and Omaha, we can probably have the public pay more for water. That's not ideal case, but worst case worst, that's how we can upgrade the systems. But what about smaller communities? Like, we have been contacted by Grand Island. Dan and I are going there next week to look at their drinking water, and they have found some evidences of PFAS in their drinking water. So they are much smaller community, and there are so many other communities that are smaller. So how do they address these problems? We really need to have concerted effort and talk with the people out there to figure out how we solve this problem. The other part is that we talk about drinking water and wastewater, right? The other part of the problem is they are getting in our agricultural ecosystem. So we have, from wastewater treatment plants, we get these biosolids or organic fertilizers that we use in many cases for farming applications. In Nebraska, we use 95% of those wastewater biosolids in farming, but they can contain a lot of PFAS. So this is an article that came out from in New York Times last year, and they have been doing series of new articles in New York Times, and it really shows how much impact it has, like PFAS has. So there was this stillborn calf in one of the ranches in Texas, and they found 600,000 parts per trillion of PFAS in its liver. But if you look at the drinking water limit for PFAS is 4 parts per trillion. So it's a humongous amount of PFAS that is being accumulating through our crops and like in food. So we have to look at all of this. So I'll just leave you there with the thought of how we can tackle this problem. And yeah, so thank you for listening. And to the next speaker. Yeah.
Thank you, Nirupam.
Good morning. My name is Andrea Bache, and I am a teaching and research faculty member in the Department of Agronomy. My title is Associate Professor in Cropping Systems, and because I am just finishing my 14th semester, just counting in the classroom, and because my title is Cropping Systems, I'm going to give you the perspective on students, the future, and cropping systems in respect to water quality. So what are cropping systems? Cropping systems are what we grow and how we grow them, right? So this is a map of Nebraska crops. So you probably can recognize that the big green in the middle is pasture, the light green, I mean, and most of the crops, that's a top land use, but the yellow and green, most of the other crops are corn and soybean. Of course, in Nebraska, we grow a lot of other crops, but you see the corn and soybean pretty clearly in especially the east and the southern parts of the state. And so since World War II, we've really been shifting away from cropping systems that were more diversified with crops and livestock into more specialized, input-intensive, predominantly summer annual cropping systems, right? And so what's the issue with that? Those systems are inherently leaky. So what do I mean when I say that? I mean that they create a greater probability of nutrient, soil, and water loss because we really only have crops growing for a small portion of the year, taking up water and nutrients. So I really think about this as a bigger issue than just how much nitrogen or nutrients that we apply, that it really is our whole cropping system and a lack of diversity that creates parts of the challenges that we've already been hearing about when we think about the crops that we grow and how we grow them. So this is a plug for a video that I was a consultant on with the Practical Farmers of Iowa. So if you just Google nitrate water quality, Practical Farmers, you'll find this. It's 9 minutes, so I couldn't incorporate all of it here. But basically what this video does is goes through the opportunity of more diversified cropping systems, and the work that I'm doing with my research group is really trying to think about how we can design crop and soil management in a way that we keep continuous roots of soil in the year all year long. So right now it's May 1st, so we are about a third of the way through across the U.S. and Corn Belt planting corn, a little bit less for soybean. That's what I heard at the beginning of the week. And those crops are not quite fully established yet, right? So if we can have more cropping systems with roots in the soil for more periods of time, they can be growing, taking up more nutrients. And so I just want to show you a couple of photos of proof that we can do this, that we are demonstrating this, lots of my colleagues and my research team and I, that we can grow different crops, we can optimize these cropping systems, make them productive and profitable. So this is a photo on Nebraska farms. This is a photo from a NRCS-funded project that I was a part of for several years. We worked with farmers doing on-farm replicated trials. Here, there was a multi-species cover crop grown. You can see that nice green brassica there in the front. You can see the residue of sunflowers. This was planted after field pea in midsummer. So this was a multi-year crop rotation, so not just corn and soybean. But if you're looking for roots in the soil, cereal rye is my favorite cover crop. I'm wearing my cover crop shirt today. Roots are counting on you. This is a great option for farmers who are looking to integrate something that can establish well in the fall and overwinter and grow into the spring. So this is, another photo from an on-farm experiment in Dodge County in mid-April. So again, I'm just encouraging you to think about what our landscape looks like right now, what it will look like in spring and fall when we have greater potential with no cover on our soil. We've been doing some experiments in eastern Nebraska at the experiment station with intermediate wheatgrass, which is a cool season perennial grass. Here we're growing it intercropped with alfalfa. So this was in late June, but you can see this nice, very full canopy of crops growing using nutrients and water. One of my favorite things about these experiments, of course, this is a crop that does not have a very well-established market yet. But we have used no herbicides on this experiment because you can see it does its own weed control and a fraction of the fertilizer that we would for a crop like corn. So this is what it looks like in the fall. I found a next level love for this crop the first year we harvested it in the fall because you can see how much cover it provides. This is in late October. Even an annual cover crop would not really have this much growth if we had planted it before. And so I'm not naive enough to think that there are not challenges to doing different cropping systems, right? So there's labor issues, there's new knowledge issues, markets, lots of issues. But what I will tell you after all of these years working with students that they are interested in soil health, they're interested in diversification, they're interested in these ideas, and they struggle like many of us do to understand how do we actually make this work and make it economical and productive on farms. But I can tell you from my senior capstone class, we've been going up and working with Lewis and Clark Natural Resources District for the last 5 years. We bring them for the trip in the summer to visit farmers who are doing some diversified practices, people who want to do some different things. We learn about their goals and challenges and then put together a management plan over the course of the semester. And I can tell you that they learn a lot. I had a hard time in trying to fit one perfect quote into 5 minutes, but you can see that the students really do gain a lot from just seeing this in real life, right? So this student was commenting that they wish more farmers had the same attitude about caring for the environment and that we are the deciding factor for how long the soil is going to serve us. So I think this speaks to another complexity of this issue is that this has to do with people, it has to do with communities, it has to do with connection and not just, the crops that we grow and other biophysical research. So thanks for the opportunity and I will leave it there.
Thank you, Andrew. And our last speaker for speed dating for scientists, Aaron.
All right. The 5 minutes is a hard one to get in, how things move through the environment, but we'll see how we can do it here. So I'm Aaron Day. I'm an associate professor here at UNL. I'm in Department of Agronomy and Horticulture, Department of Biological Systems Engineering, and as well as a courtesy appointment in the same department as Jesse up at the medical center here. And I'm a vadose zone scientist. That means I study the unsaturated portion of the earth from the ground down to wherever the water table is at. That's where I find my expertise lies, and studying how things, particularly water and contaminants, move through that area. So a number of you that may have seen some of my talks before have seen this slide here. I always like to kind of approach the situation just wondering, trying to imagine where does a water droplet go from the time you release it. Maybe it comes out of an irrigator, maybe it comes down from the sky, maybe it's going out with a pail of water from the kitchen or something. But where does that water go? And where's it going to be at different moments in time? At this point in the semester, it's easy to also think about the same things that are happening to our students. Andrea just mentioned students and their struggles and everything. We're with them for a little while. We know a little bit about them, but then we release them out into the world. They go out and they do their thing. And we hope that they're able to do some good. We hope that they picked up some good things, but we also know that they probably picked up some bad things along the way too, you know? And so what is their story? What's their journey going forward? And we can think of water very much the same way and what it has picked up. And the things that it picks up has different personalities, if you will, for example. We've talked about a number of different types of contaminants up here. If you have arsenate in the ground, well, it tends to be more like a homebody. It likes to stick to a mineral and stay there and just kind of hang out for a good while. But if you've got something like PFAS, well, it likes to stick to where the air and the water interface is at. And it might be like casually taking a stroll through the states here or something. But nitrate, it loves to just hang out in the water. And when that water goes, it goes along with it. So it's more like our globetrotter, you know? So different contaminants have different personalities and preferences, kind of very similar to humans, if you will. So where are we at confidence on where they go and what they do? Well, we're not privy to that information largely, just like the students that we interact with, just like all of us. We're all going to leave this conference and go do something. We have some bit of an idea of maybe what all of us are going to go out and do. Just since that we're here together, we have similar interests in a regard, but we're not privy to seeing what that journey forward goes. And in the ground, it is very much that. You see something going in on the surface, but you don't know where it goes beyond that. You're not privy to it, but you might get glimpses of it later on in time, here and there. So I wanted to just give kind of an overall feel for what it is to study something that you can't see, or even see where the train or the airplane or the vehicle or the bicycle goes. So one of the things that we look at, starting with, is where it's easy to look at, where things start. So we have projects that look at just the very surface. What does that look like in one spot or another? And at particular times in the year to where we know that water or whatever it's carrying, nitrate particularly, may be taking a different journey from one location to the next. Just how all of us are different, we're going to take off on different pathways. The same thing can happen when you have the same irrigator, the same nozzle going down, the same planter, the same band of fertilizer that went down, the same soil series. Everything looks about as homogeneous as can be. There's still variability within it. So we try to study what kind of variability is there, and try to decompose that to see what kind of structures are there. What can we learn? What stories being told about the differences in the people, differences in the water droplets and the stuff that they're carrying when they first take off. We start there. Then we go down and we acknowledge that, well, sometimes people funnel, or water funnels into areas. And once they funnel into that area, boy, they really take off and they'll keep funneling into that. So their pathways look different. Their preferences and tendencies look different. We look deeper down into the ground and we try to figure out where's the stopping points, where's spots where they tend to accumulate, where are things not accumulating. This is one of our projects that we have going on right now, to where we're looking at areas to where there's little nitrates down deep in the ground, but if you look at the surface and all the areas around it, there's no good reason why it should be low. You expect it to be high. What is going on there? What's that story? What's that history? And we're investigating what could be going on in those areas. And then you get sometimes a snapshot kind of along a pathway, and you can see some dynamics. This is some research that Richard Ferguson and others started back in '86. This is some samples from 20 years ago. We're out sampling again this last week, 2 weeks for it, and you get a little bit of a glimpse of what that pathway perhaps looks like going down into the ground. You see a hint of the dynamics. You start off high near the surface, boy, you plummet down, but then you come back up, and then you stay somewhat fine, and then you start trailing off again. There's a history imprinted here. And so a large part of studying the movement in the environment is looking at snapshots, looking at patterns, and trying to infer what is that history that led to these patterns. Because studying something that moves in a place that's not easy to access and you can't physically see it is really difficult. And so this is a common approach here, is to look to see what kind of characteristics there are, and then read that journal, read that diary, and try to infer what the history and the movement across time was at. So that's what I have for you.
Thank you, Aaron. So we have a little bit of time for some questions for our panelists. And if you have questions, please feel free to go up to the mics or raise your hand, and we can have somebody come over and ask question, or hand you the mic so that you can ask your question. So we had a number of different diverse perspectives here. And one of the reasons we have these diverse perspectives is because challenging things need a lot of different people. One of the things I was kind of curious, just to kind of kick it off, and this is a question to all of you, with this being such a diverse and complex issue when we're talking about contaminants, and we saw everything from things that we've been addressing for decades to newer things that we're now starting to see and address now. What are opportunities for us collectively moving forward? What are the positives that we can do moving forward to try to address some of these issues? Either the ones that we've been facing for decades or the newest ones that we're facing now. And I'm just going to toss that one out there and happy to hear any thoughts. And if you want to say something negative too, that's okay too. Here, Bob.
Yeah, that's a very interesting question. And I think we have been talking about, like, I work on PFAS, but I have been also involved in projects where there are nitrate and phosphorus issues are discussed. And there has been a lot of questions about how do we deal with legacy contaminants, emerging contaminants, and contaminants of the future. And they are not separate. We treat them separately. I'm working on one topic, another person is working on another. We treat them separate, but they are going to exist in tandem with each other. So, and I think, like, we have been in environmental engineering community now, and in industry, we are talking about one water solution, like one health, same approach, one water, how we can address different contaminants at the same time and understand their relationships with each other, and, like, how do you address that? And I don't have a specific solution for it, but I think that's where the discussion needs to happen more and more, and not like segmented, but how we can come together and find the linkages, like looking at the history of contaminants and how they have been in the environment, how they are going into the different compartments. And once we try to address one part, how that impacts the other part, right? So, so that's my take on this.
Go ahead.
Thanks. I borrow sort of the tail end of that, thinking about how you can sort of build upon what you know from other sectors. Thinking with my lens, which is as an epidemiologist who's studying health outcomes, the work just sort of by design has to be really multidisciplinary, because I can take monitoring data and turn it into some estimate of exposure, but I really need the folks who know what exposure means and how, how contaminants move through the environment and how people come in contact with them as part of doing this research. So I think looking for opportunities to sort of share knowledge and work together on projects is something that's going to help move all of the public health piece forward in particular.
I guess I'll add, so my first slide was about sort of the history of connecting water quality to human health. And I don't know if I mentioned this or not, but it's really a pretty young science. And we've made some tremendous strides in connecting the incidence of human health to specific contaminants. We've done a lot of work, and we have a lot more understanding than we did even 10 or 20 years ago. I think the other thing that I've noticed that I really appreciate is how people are interested and aware and really want to learn about water quality, how connected we are to the earth, to our water supplies, and people in general seem much more interested and willing to try to do something about it.
Andrea or Aaron?
Yeah, I would say that the connectedness of all of us is a big thing. You know, some of these issues, as you noted, they've been around for decades. They will continue to be around for decades because the environment's holding on to them and will slowly keep releasing them to some point and stuff. But we've got that knowledge behind us. We're building on something. There's a large mountain of information that's available there, but it just, since that we still work on it, it shows how big of a challenge we have going forward. And so with the advancements in technology and data science and interest in the way that we can connect with each other, even just being able to get up here and have this conversation and document it and record it and preserve it for others to see later, I mean, it builds momentum. And so that momentum, I think, is still strong, and it looks great for the future.
I would just really briefly say, I think it's a great advantage that we have under the Nebraska system, the health people, University of Nebraska Medical Center, and the agriculture school, because it's not like that everywhere. It wasn't like that when I was a graduate student at Iowa State a decade ago, and I agree that we've advanced our knowledge. So I think it's an advantage for us that we can work together more seamlessly and not against each other, and show that, you know, we can do better in the way we produce our food, and also that these models do have a benefit for public health, different models. And I think we got to show people examples, like the example with my students. I've also done some research with the Shell Creek watershed, which is just northeast of here, and they have had community engagement and leadership in advancing conservation, and have been able to, I see some heads nodding, so probably people are familiar with this example in the state, delist the Shell Creek for atrazine impairment. So there are examples of people working together and making progress, and just building those and highlighting them, I think, is really important.
Nice. Any questions from the audience? And, oh,
We'll have one over here.
please.
Hi, I'm from Texas, and I'm the director of a conservation nonprofit there, and we work closely with the oil and gas industry. I've really enjoyed this discussion of cross collaboration. So we are right on the edge of the Permian Basin, which is the largest oil and gas basin in North America. So for every barrel of oil we produce, we are producing 3 to 5 barrels of contaminated water. And we really have an environmental disaster there, and that the oil and gas industry is really focused on finding a way to utilize that. And so it's more than a question, how can we collaborate? I know at Texas Tech, we're looking at water quality. We have now the ability to test for unknown unknowns. But it's a disaster, but it's also an opportunity. This is water that would have never been accessed before. It's new water. So, because it's coming out of this porous, fracked, process, and we'll be looking at increasing production by 5 to 7 times in the next few years. So this is millions and millions of barrels of water a day. So I'd love to know, either now or later afterwards, how can we work with you all in what you're doing?
Nice, thank you. And with that, because we have that transition, so is there ways that we should be working together, or things that you would want to share with the audience that you haven't been able to say now or up to this point? And so with that, I'll open it up for whoever feels most comfortable starting that off. Aaron, I see you.
Well, I would just say, just bringing things up just as they just were. I worked in North Dakota for 9 years on oil and gas and fracking waters and stuff like that, and spills and repurposing. So just saying something, making a connection, and being like, yeah, we've worked on that. Hey, let's have a conversation later on. That's a great starting point. So we'll follow up.
Nice.
Yeah, and I think the point is water reuse is a major issue, because water scarcity will be there. So anywhere we can find water that we can repurpose and reuse is a great resource itself. So yeah, that happens a lot in California, in West Coast. It happens a lot. They have been doing repurposing of water for many, many decades. But I think that concept needs to be out there for others too. So we do a lot of water treatment, but how do we capture the products, chemicals out of the water and reuse the water will be a very, very important thing for future. Yeah. We'll be happy to collaborate if anyone has. Yeah.
I think one great thing about Nebraska is we try to be very practical. You know, we try to think about how the science we're doing applies to everyone, how we can make lives better, particularly for rural U.S. and other countries. So I think we're very collaborative. We're open to help. We really want to solve these big problems, and I think we have a great team of expertise here that is ready to help.
Andrea or Rena, any last thoughts? Or all right. Well, with that, I want to thank our first panel, but don't go anywhere because we have a second panel that's going to be people working on the ground, talking and dealing with some of these particular issues that we just talked about here. Also, I want to thank everybody here for participating. I greatly appreciate it, greatly appreciate your time. And so with that, thank you very much. At our campus, talking more broadly about some of their work that they're doing at the National Cancer Institute, and that she's done looking at some of these contaminants and some of these environmental exposures and how it relates back to, in particular, cancer. And so the whole premise of that first one was high level. We had everybody from individuals that are monitoring the contamination to trying to understand how is this impacting human health, to potential solutions to some of the issues that we're facing, either through systems that are in place in our like cropping systems that can reduce nitrate, or systems that we can potentially develop to remove contaminants such as PFAS, which are more new, novel contaminants. And this session has a little bit different flavor to it. So we had a lot of academics, researchers. Now we're going to talk to practitioners and people working on the ground. And so with our next group, we have Brandon Honeycutt. Brandon Honeycutt is an owner and partner in Honeycutt Farms here in Nebraska. We have Brian Buckner, who is the general manager for the Lower Elkhorn Natural Resource District. We have, where's Lyndon? Lyndon Voigt, who is the general manager for the Central Platte Natural Resource District. And we have Laura Nagengas, who now has a new position, but was the environmental health education extension educator here in Nebraska for our extension services. And so if our speakers are ready, we're close to being ready, but our first speaker is ready. So I'll hand it over to Brandon. So really appreciate it. Thank you so much.
All right, thank you, Jesse.
Oh, do we get the mic on for Brandon?
Maybe not. There we go. All right, thanks, Jesse. Good morning, everybody. I'm Brandon Honeycutt, as Jesse mentioned. A few of you probably saw me the other day on the Human lecture. So you're going to see some of the same slides because they're really water quantity and water quality go together. But I want to talk a little about what we're doing on our farm, a little bit what farmers are doing in general, specifically because farmers are the front line of this discussion. Roughly, there's about 9 million acres, give or take, of crop ground irrigated in Nebraska. So when we start talking nitrate issues, when we start talking a lot of these things, it comes down to irrigation. Because we've done a better job of irrigating, so we're not putting as much water on, but there's still a lot that goes on in the nitrogen phase. So some of these slides are familiar, like I said. So when we're thinking about irrigation, up there you see the center pivot. They become more efficient. We've transitioned a lot of ground away from flood irrigation to pivot irrigation. The middle picture up top, you can kind of see it. It's drip tape. So, there's been some movement into drip tape in Nebraska in a lot of areas. Keep all that water underneath the ground and just irrigate as you need it, add the nutrients when you need it. And again, we can monitor all that from our smartphones, which has also become a big value when it comes to like if we're fertigating, and if a pivot goes bad, it stops in the middle of the night, you're now not just pumping on a whole bunch of fertilizer in one spot. You get the notification, you can get up and go out and see what's going on. The other key element of this is what we're doing in the field. So up in the upper left-hand corner, you see corn growing in a cover crop. So one of the ways we can help mitigate some of the risk when we talk about nutrients is let's get a cover crop out there. It has its own challenges. There's a lot of us that are big believers in cover crops, but our challenge becomes how do we get them planted? We don't have the labor force. We're trying to do this after harvest, and corn harvest might go into November. God forbid it goes into December, but it can. So how do you get this cover crop growing in a timely manner to make sure you get the most benefit out of it? We can do it behind soybeans pretty easily, but for those of us who grow mainly corn, this becomes a challenge. The middle picture is a strip till machine, and I mentioned a couple days ago that I came right from the strip till machine here. I was up till about 12:30 last night, strip tilling a field, trying to get ready for it to plant, but that helps stabilize the soil a little bit because we're keeping the residue on the field, but having that nice clean strip. The other picture is one of us when we're applying nitrogen with an applicator in the growing crop. Now, why is this important? Because a lot of times you'll see farmers start putting nitrogen on in the fall. As soon as November 1st hits, it's supposed to be soil temperatures of 50 degrees. You'll see anhydrous rigs running all over Nebraska. But as you saw from the presentation earlier, when you start thinking about when the main annual rainfall comes in, that fertilizer is sitting there for 3, 4, 5 months before we ever get a crop in the ground. So now you have this fertilizer sitting there, getting rainfall on it. Where's it going? It's not going to the crop. It's going into the groundwater. And we as farmers need to understand that. We need to understand that we have to have a change in practices that will make sure that we are keeping the fertilizer where it needs to be. We could argue how much we over-fertilize. I do believe that every single, whether it's a soil lab, the University of Nebraska, everybody's recommendation for Nebraska is too high. And the University of Nebraska is the best at giving us probably the closest amount we need, and it's still too high. So we need to be able to say, hey, what is the amount of fertilizer we need to grow the best crop we can? When can we get that on? Maybe it's with a center pivot. Maybe it's with a biological. But it's become a giant challenge for us because we're the ones who are living in the small towns when we start talking about nitrogen issues. Our small town, we don't have a nitrate issue, we have a manganese issue. The small town 15 miles north of me doesn't have a nitrate issue in the water. They have uranium, which is related to nitrates. So what are we going to do when we're fertilizing right up to a town and they can't find a place to drill a well to bring in new water? So for us farmers, we have to be the ones who are willing to say, what are we going to do to make this better? And there's a lot of work being done on that. As we mentioned, we've got cover crops, we've got biologicals, we have better irrigation practices, we have better nitrogen practices, but we're still not there. And I think the main reason is nitrogen is cheap. So if I want to make sure I have an insurance policy, my easiest insurance policy is to over-fertilize. And it may be right before the crop's growing, might be in season. But as a farmer, I need to understand that until those roots hit that fertilizer, it's not just sitting there, it's not just waiting. It's moving somewhere. And we're slowly starting to understand that. But we need a giant change in our attitude when it comes to this. And that's on us as farmers to make sure that we are looking at things the way we can do it better to protect our neighbors, to protect the next generation. We have some tools out there, but we're always looking for more. There's always new ones out there, but we need to get better at it. With that, thank you very much.
Thank you, Brandon. Appreciate it. And our next speaker, which I believe is Brian, that's going to be talking about some of the work that they're doing up in northeast Nebraska. My stomping grounds, former stomping grounds.
Good morning, everyone. I'm Brian Bruckner, General Manager for the Lower Elkhorn Natural Resource District up in Norfolk. As Jesse mentioned, he's from that neck of the woods. For those of you who aren't familiar with us, We're up in the northeast part of the state, about 2 hours north of here. Agriculture is the driving industry, of course, as it is for much of Nebraska. Norfolk could be the largest community. And as you can see by the map, there are many, many smaller communities, 1,000 population or less. They're evenly distributed. Groundwater, I think it's safe to say that groundwater is the sole source of drinking water for all residents. So hence the need to protect groundwater resources. Up in Lower Elkhorn NRD, of course, the natural resource districts have regulatory authority over groundwater in Nebraska, and we have had to utilize that. Some of the monitoring activities and the regulatory activities that we've engaged in would include, going back as far as the 80s, we had started comprehensive monitoring of groundwater in our district for nitrate specifically. That exploration identified areas that we had nitrate levels that exceeded the 10 part per million threshold. And it met our triggers to delineate groundwater management areas. We have had to expand that twice because of additional monitoring and data that it has supported that and showed that we had other areas that had greater problems. And of course, the regulatory policies are targeted to the areas that warrant the greatest attention. As I mentioned earlier, the predominant land use is agricultural. A third of it is also irrigated. We are a diverse district. Corn, soybeans, and alfalfa are our main crops grown. We also have lots of livestock. For those of you that have been up in our neck of the woods, you'll see it when you drive through the landscape. A lot of beef feedlot operations, cow-calf operations. We've got swine production. We've got a growing presence of poultry. We had egg laying for a lot of years. We're now seeing a lot of meat bird production up in our neck of the woods, and there's also dairy. I will say, though, that, of course, the production systems around livestock once were more dispersed. Now they are more concentrated, and numbers have increased in units. So, as I mentioned earlier, we've got a variable district when it comes to soil types. We have locations with very coarse textured soils, sandy soils, primarily in Pierce County, where we've got our management area. We've got fine textured soils, and the topography is quite different as well. Other variables that influence this groundwater quality issue would be the depth to groundwater. We have very shallow locations, less than 10 feet or around 10 feet, to locations that would be up to 200 plus feet in depth. Precipitation is average about 28 inches. It can be very variable. We can't control the climate, the weather, and that plays into this issue as well. In 2007, we recorded almost 38 inches. In 2022, 13 inches. And of course, that doesn't come in even distributions throughout the year. And we can often get rainfall events like we had last spring, where we had a lot of product, a lot of nitrogen, a lot of fertilizer on the surface, and we had significantly above average precipitation in the spring and caused leaching of some of that nitrate. We're using a variety of tools to address this issue, both voluntary incentives and our regulatory tools. I'm sure many of you in the room have heard about the Brazil management area. In 2012, we joined forces with 3 other NRDs. That allowed us to tap into some additional incentive dollars to promote conservation. It's a voluntary plan. We have additional cost share opportunities for growers in that neck of the woods. As far as our regulatory areas, that map, the violet area, is our phase 3 area. That's the portion of Pierce County where water quality is most negatively impacted. And then, we have the blue areas, which is our phase 2 areas. Those areas, the growers have to comply with a host of regulatory requirements, all addressed at someday remediating that groundwater quality matter. Other tools that we're using, of course, education. Everything we do, even though we have regulation activities, we try to use an educational focus to implement those. We have a website that's specifically developed for nitrate issues. If these presentations are shared, that is a live link. If you'll click on that, you can get into that website. There's a lot of information there about public health, agriculture, and then some of the research that's ongoing about that. We have identified and developed programs. Obviously, we have financial assistance programs for some of the requirements, the soil and water testing, things that we require. We've also promoting the chemigation concept, where growers use their irrigation equipment in the well and the water stream to deliver nutrients, spoon feeding them to the crop as they need it. We have identified and allocated resources for a domestic well testing program to help the public understand what is the quality of my water. And some of the things we're monitoring not only is bacteria and nitria, but herbicides and glyphosate, some of those other chemical compounds that might be out there. We've also leveraged, the state dollars a couple of years ago, the ARPA funds that came through. We help well owners get their wells registered to help them get eligible for those funds. We've also allocated local resources. We'll provide some funds to help people install a reverse osmosis system on their private well. Of course, that's simply addressing the problem and making sure that people have a safe source of drinking water. That doesn't fix the larger problem. Collaboration, we have been partnering with folks at the Med Center and at university to collect samples from privately owned wells, some of the health implications, we're very concerned about that, and to help benefit that cause, we've engaged in some sampling efforts with those organizations. So I'm way over time, so I'm going to step down.
Appreciate it, Brian.
Thank you.
And now for a slightly different perspective from a different NRD, Natural Resource District here in Nebraska. Linda.
Good morning, everyone. My name is Lyndon Vogt. I'm the General Manager of the Central Platte Natural Resource District. And I'll try not to hash over some of the same things Brian just visited about. Just a quick history. The NRDs were formed in 1972. We are a political subdivision of the state of Nebraska. We have taxing authority, and I was trying to figure out this and forgot what I was going to say. And we're all run by an elected board. So our boards range from about, I believe our smallest one's about 7 directors, and the largest ones are 21. So it is interesting to see how the different NRDs and their boards manage differently. Even though we all have the same 12 responsibilities, I would have to say that the majority of our time and money are spent on about 3 of them 12. It's water quality, water quantity, and flood control is where the erosion and sediment and flooding issues. So them 3 things by far take up the majority of our resources. So just really quick on Central Platte NRD, I saw how quick 5 minutes went for Brian, and I have a feeling mine's going just as fast. So we do have a monitoring program. We have about 20,000 irrigation wells in our district. Our district's 2.1 million acres, and 1 million of them are irrigated. Of them 1 million acres, actually it's 1,030,000, about 70,000 of them are commingled, meaning they have a surface and a groundwater source, and about 30,000 of them are surface water only. So we are a heavily irrigated, groundwater irrigated district. We sample about 900 irrigation wells for water quality. We have them on a 3-year rotation, so we're doing about 3 a year. We do the eastern part, the western part, and the central part of our district. So we're on a 3-year rotation, and we've been doing that for over 30 years. So we have a pretty good idea of what direction our nitrates are going in our district. And we also have a VADO sampling program that we do. We started that in 1996. We came back, that was in conjunction, I believe Dan Snow helped us with that in 1996, and again in 2016. We come back to them exact same sites to get an idea of what's actually going on beneath the root zone and above the water table in our district. Is the loading on the top, on the surface, is the same as it was 20 years ago, or has it gotten better? Have our practices, have our educational efforts and our producers and our practices gotten better? So now it's been 10 years. It's hard to believe it's been 10 years since 2016, but so we're probably going to have to come back and look at them again. We also do a domestic sampling with quite a few individuals, domestic wells. The last couple of years, we've gotten into more and more uranium sampling along with them nitrate sampling as a result of some studies that have come out of the university. Our educational programs, we have spent a lot of time and effort on education, mainly our nitrogen management program. Brian talked about their phase 2 and phase 3 areas. We're kind of in that same boat. So we get, I don't know, between 6,000 and 7,000 crop report forms a year from our producers, and we have about right at 700,000 acres of our 2.1 million are above 7.5 parts per million for nitrates, and they're required to supply us with a crop report form with their soil samples, water samples, cropping history, yields, and that is there is an educational component to that where they have to do a 4-year nitrogen management program too as part of that. On-farm research, I think, is huge, and we have had a partnership from the university for 40 years now doing on-farm research. We've had over 400 sites of on-farm research, and I think as a result of that on-farm research, we know that we need to go in. We need to be looking more at in-season applications of sensor-based application of our nitrates. I agree 100% with Brandon. I think the university has the best algorithm out there, but I do think they're all too high. And we've done a lot of work on, we've done quite a bit of work on a dashboard that we can put all of our producer data into it, and also all of our fertilizer dealers out there, their formulas for making recommendations. And I can tell you that there's a tremendous amount of difference in recommendations to our producers. So we look at our producers and want them to do a better job, but the people that they're working with that are making them recommendations are all over the place. And I think that can be addressed with in-season sensor-based applications. So where we headed, what our goals are, we feel very fortunate that for the most part, we've stopped the increase of nitrates in our district. We've required these crop report forms since the mid-'80s in our education programs. And so we feel like we've kind of got that topped off. It's kind of slowly heading down. It's the working with producers one-on-one. We have probably 10% of our producers that if we could sit down and work with one-on-one, we could see that nitrate level come down much, much faster. So I think with that, I'm going to wrap it up. I'm already a few seconds over, so.
We've built in time. I appreciate it.
So really the last thing I'll touch on then is investing in regional research. I think as we move forward, we really need to look at not only the on-farm research or the research within our district, but as I look at, I border the upper Big Blue and the lower Loop, the 3 NRDs together have 1/3 of the total irrigated acres in the entire state of Nebraska. We have almost 3.3 million acres between the 3 of us. We need to be doing that research together. We need to be looking at how we can help out our producers, and I think the future is bright. We just all need to get on the same page.
Thank you.
Thank you.
And last, Laura will be talking about some of the public health engagement around some of these issues.
Okay, thanks. Yeah, I'm happy to be here today. My name is Laura Negengast. I'm an extension educator that focuses on water quality and public health. I work closely with Dr. Bell and his team, the Water Climate Health Program at the University of Nebraska Medical Center. So today I'm going to be talking about our education and engagement around water quality and public health. So I want to start off by talking about some of our key stakeholders that we work with most, those being healthcare providers, public health departments, natural resource districts, and the general public. So we've focused on healthcare providers and public health departments because they're typically seen as trusted and key sources of health information. You know, healthcare providers have trusted relationships. They span the entire state of Nebraska. They often have personal and more intimate relationships with mothers and children who are at-risk populations for some of the health impacts that we've been talking about today. Public health departments, too, span the entire state of Nebraska, also talk about health information, and they've actually shown a strong interest in working in the water quality space, and I'll talk about that a little bit more later. Natural resource districts, as we've just heard, have worked constantly in the water quality space, and so collaborating with them, they have strong relationships with farmers in the agricultural space, so that's another avenue we work to collaborate with, and then of course the general public. So trying to reach just as many people as possible to ensure that Nebraskans have safe and clean drinking water. And so we do this through numerous ways, whether that be in fields with farmers, attending conferences, making videos online, social media campaigns, physical copies of programs and information, mass mailing campaigns. So pretty much any way we can educate the public, we've been working towards. I want to touch on a study we've been conducting at the Med Center. So we were trying to understand the education levels of healthcare providers and natural resource districts on water quality. So how have they had any training? How confident are they of talking about it? And these are a few graphs that we've put together so far. As you can see on the left side of the screen, those represent healthcare providers, and there is a significant lack of knowledge and confidence talking about water quality and health to their patients. On the other hand, natural resource districts have more confidence talking about health impacts related to water quality, but they rarely talk about this topic. So the next step of this study, which we're working on now, is how to close these gaps. This survey that we initially sent out it was very long, and part of that survey was what kind of resources would help close these gaps if they were available. And so our phase 2 of this project is working to close those gaps, creating educational materials and communication materials. This is another project we're working on with public health departments. So as I mentioned earlier, they have shown interest in working in water quality and health. And so that really stems out of the fact that their communities have been asking them about water quality. And there's been a kind of miss in accessibility of resources for them. And so we came up with a plan to create a resource toolbox aimed at public health departments and their needs and wants for their communities here in Nebraska. And so this toolkit is built. It ranges from just the basics of water quality all the way to how to talk about water quality with various audiences. It's not publicly available yet. We're in the stage of reviewing and improving, but we hope that it will be published soon as possible and it will be available widely. Whoever wants to use it is free to use it. And then lastly, I just wanted to end with a slide of us in the community. We try really, really hard to get out there, take this science and research that's happening at the Med Center and bring it to folks in Nebraska. And so here are just a few pictures of us in the community. So whether that be speaking at a statewide conference, a national conference, international conferences, or hosting a trivia night at a bar here in Lincoln, we again, try to come up with creative ways to educate the public. The trivia night we did in conjunction with the Lower Platte South Natural Resource District here, and it was a really great event. Again, the bottom pictures, attending conferences, booths, community nights, health fairs, and then all the way to we attend a day at the Lincoln Zoo with people with disabilities can come and learn about water. So that's what I have today to talk about. I know I went really, really fast, but I am over as well. So happy to answer any questions on the panel. Thanks.
Thanks, Laura. Appreciate it. All right, and so we'll move into the final part. We have time for some questions of our panelists. If you have questions for the panelists here or for the previous panelists, please feel free to go and use the mics or raise your hand, and we'll find somebody to come over and bring the mic to you. And, you know, we saw that higher level perspective, and now we're seeing some of the things, kind of the boots on the ground of addressing these issues. This is to all of you, but a little bit more to you, Brandon. What are some ways that we can incentivize farmers around addressing these issues? And so, you know, we have a lot of different things, but nitrate was kind of the focal point of this second one in particular, and that's partially because of the concerns within the state. But what are ways that we can incentivize farmers and incentivize the broader audience as well to help tackling this issue? And feel free, Brandon, or you can, or if somebody else wants to jump in first. So,
you know, from a farmer's perspective, one way to incentivize, you know, I know the NRDs do a great job of some cost share programs to try to get get technology into farmers' hands. I think that's one really good way to do it. Farming as a whole is very expensive, and trying to add in that next tool, if you don't have much confidence in it, becomes a challenge. So I think there's the cost share incentives that are out there. If you can really work with some private industries to get tools into farmers' hands. Sometimes it's good to give some free stuff out that certain farmers that will really take a key interest in it, and other farmers look to say, okay, they're utilizing it. How does this play out for my farm? I'll just use a quick example. We had actually purchased the equipment. We were using water sensors in the ground, and we were the only ones in the area. And tell the quick story because my uncle, I knew exactly his watering schedule. I knew it to a T because I knew when he'd plant and I knew when he'd start that pivot. And one year, all of a sudden, I realized that pivot didn't start the week it should have. And the next week, it didn't start. And I think it was a week later, I saw it start. I went, well, that's odd. I don't know if he's sick. Has he had a stroke? What's going on here? And I looked out there and I saw a sensor out there. And I went, got it. He now trusts the technology. So there's some of those incentives that need to go out there, before we get to the next stage, which is the hammer.
Yeah. Nice.
Go ahead. I think all of us want to avoid the hammer. And speaking from an NRD's perspective, it's the last thing we want to do. I think the technology, it's getting the technology in the right people's hands, in the producers' hands. I mentioned the in-season, the sensor-based in-season application of nutrients. I think that's a huge next step in addressing our water quality needs, and I think it's right before us. It's getting that. We offer a cost share program on that, producers. I know NRCS does too. You know what I mean? But sometimes it's getting them leaders in the industry to do it first, so other people will follow. And I think we are right on the verge with that on the in-season application of nutrients, which hopefully will help us address a lot of water quality concerns that we have today.
So in our district, a thing that I think has made a substantial difference is human impact. I mentioned the Brazil groundwater management area. We've got a project coordinator, and that's a voluntary program. We've got a person that is tasked with communicating with communities, with farm operators, and I didn't have a map of the practices that we've been able to establish that weren't there prior to this project. And I'm confident that those practices wouldn't be on the landscape if it weren't for that conversation that happened across the hood of a pickup. We've also got a success story in our Willow Creek watershed. We have a conservation planner there working. We've had chronic water quality problems in our Willow Creek reservoir. We have gotten a lot of cover crops established on ag lands in that watershed. 2024 was the first year that we didn't have a positive hit for toxic algae. We're giving a lot of credit to our coordinator on that. This year might disappoint us, I don't know, but there's those kind of things. We've also entered in an agreement with NRCS. We're going to be establishing a position working primarily on source water protection. So on working lands that intersect with well water protection areas. And we have 100,000 acres of land between our district and the Lewis and Clark NRD. And that individual is going to be going to work trying to get conservation on land in that area. So those are some good things that can benefit some of the things that the others have talked about.
Nice.
I guess the only thing I would add is not quite farmers, but it's the farmers' wives. Reaching them. We know that women make over 80% of the decisions regarding health in the household. So being able to reach them to potentially put in a filtration system on their farm or on their private well is a goal. And that would be maybe potentially using healthcare providers to do so.
Nice.
You have a question over there.
Oh,
You have a question?
oh, I'm sorry. Yes, go ahead.
Thanks. I work on nitrates and groundwater issues in Oregon, and sounds like you all are really proactive here, and I salute you for the work that you're doing with with the farmers and the residents in your communities. I've got a couple quick questions. I know from my experience, I appreciate that you're offering free testing and point of use reverse osmosis systems to help reduce some of the contaminants. And
there are folks that join, they should be able to test.
okay, and thanks. And testing, yes, there was anyways to testing, you got to maintain those filters so they're effective. And another thing about those systems is they're only really good for nitrates up to about 25 milligrams per liter. And so just wondering if you're also offering other options like bottled water or helping with bottled water or connections to rural water or public water systems. And then the second question is around application of fertilizers. I like what I was hearing about better timing of application. I'm wondering about like manure waste, manure management and land application of farm waste, municipal waste, ag producer waste, if those same conversations are happening around that as well. Thanks.
Thank you.
I'll tackle the first question. When it comes to the treatment systems, yes, they're only capable up to certain levels, certain thresholds, and we have had, unfortunately, a couple of private well owners that have had to install 2 systems to get that water down to a safe level. And maintenance is key, of course. That system's only going to continue to protect that family if they continue to maintain it. And so, we've been communicating with them to make sure that they're aware of that. When it comes to rural water systems, in our district, we operate 2 rural water systems. There are 3 in our district, 2 are operated by us. We see growing demand and importance for that moving forward in the future, because we not only have nitrate, but we have manganese and iron issues in a good part of our district as well. So the challenges are vast. And we hear about PFAS and all these other things. We got to get our hands around the problems that are right in front of us. So
I'll tackle your second question. Yeah, we do look at timing of fertilizer, and we're also looking at livestock waste. That's all considered fertilizer. It's considered nutrients. In our phase 3 areas, we don't allow fall applications. We used to have a huge fall application of fertilizer, especially anhydrous in our district. You just don't see that anymore in the Central Platte NRD. And so in our phase 3 areas, we don't even allow the fall application of nitrates. In our phase 2 areas, we don't allow it on sandy soils. In our phase 3 areas, we don't allow it at all. And so that has helped us tremendously, to be quite honest, with our nitrate concerns. But we do consider the human waste, which is fairly small in our district, but there is some. But in the livestock waste, all falls within that same realm of management as fertilizer.
Test.
There.
Ooh. Test.
No, this isn't a test.
we're failing.
Yeah, that's right.
Test. There we go. That was a lot better.
It's not, I promise you. All right. Any other additional? Oh, I see another question.
I mean, I can wait if there's another answer to this question. So Nebraska is a really small state. I've realized just listening to this panel. I grew up in the lower Elkhorn NRD, and my dad's been on the board for, I don't know, forever. And we farm in the Central Platte. So I have a huge amount of respect for the work that our NRDs do. My question surrounds some of the research that's going on. The hat I'm currently wearing is the Assistant Dean of the College of Nursing in the Lincoln Division. And are there research projects that are looking at rural cancer clusters surrounding private wells? Because there are quite a few areas in Nebraska that have popped up with hotspots or rural cancer clusters. That would be question number 1, and how can we collaborate? And 2, how do I get you in front of nursing students in our public health classes? Because in the courses they take, the phenomena we see is that nursing students come really interested in ER and acute care, but the longer we have them, the more we can have them look outside of of the hospital setting to look at social drivers of health. And so how can we collaborate to help shift that focus outward to their environment?
You want to take it?
Oh, go ahead.
No, you can take it. Talk about the pediatric cancer.
Yeah, and so with the studies around pediatric cancer, I don't know if Dr. Rogan, Ellie Rogan, there's Ellie. Dr. Rogan has been doing some studies here in Nebraska looking at some of these exact issues. Dr. Rogan is a professor at the College of Public Health. And then Rena, in Iowa, you guys have done work looking at private wells as well. And if you are interested and happen to be in Omaha tomorrow, you could come and see Dr. Jones's presentation, which she might talk about some of this. Rena, is there anything that you'd want to add to that? Yeah. Anything that you wanted to add to that as well? I'll repeat it.
Okay. Great question. A lot of times the cancer cluster investigations are done more at the state or local health department level or the CDC, which may or may not exist in terms of the group that does that. But
That's a follow-up question.
yeah. But at the National Cancer Institute, we are doing area level studies of a lot of these agricultural contaminants and cancer.
Thanks.
And just to repeat that, there are studies that do occur at the local or state health department level, but there are broader studies that are happening within the National Cancer Institute. But there is still a lot more work to be done around that. And rural areas are particularly difficult because cancer clusters are in such a small population size, and it makes it harder to identify those. Is that fair to say? I'm intimidated to be in front of her saying anything in that regard. And any additional thoughts to the point that was just made?
So I mentioned our efforts to collaborate with University of Nebraska, Lincoln, with the Med Center. We're working with Ellie and her other colleagues to do some sampling of privately owned wells, and then they're trying to draw some relationships there. When it comes to interfacing with nursing students, public health departments, we're happy to contribute in any way, shape, or form that we can. We've been trying to interface with public health systems, public health departments, to help them gain an understanding on what we can offer so that they can communicate that to residents of Northeast Nebraska.
Dr. Bell, could you explain where they could find the publications or information regarding you and Ellie's work or other work? What's published? Where should they go to find it?
Yeah, you can come to our website. And so at the University of Nebraska Medical Center, the Water, Climate, and Health program, we have a lot of this information up on our website. You can also look at places like the Environmental Public Health Tracking Programs, which Nebraska is one of those programs for now. That funding might go away in the near future, likely will go away in the near future, but we're going to continue doing a lot of this work to try to address and understand some of these challenges and make sure that we're educating the people in Nebraska around these challenges as well. I know we're at the very end, but I wanted to throw one more thing at you all. You're all experts. You're working on the ground. We have other experts up here. What is a challenge or something that you wish that other people were doing or addressing or working with you? What would be the big ask? And I'll just throw that one out there as the final thing.
I think the big ask from me would be more direct. Don't beat around the bush. If nitrates are causing cancer and we know that, let's get the word out. If in-season application of nitrogen is the answer, let's all get behind it. You know what I mean? I'm not pointing the finger at anybody because I don't know that I know the answer either. But it seems like we just be more organized as a group to get behind a solution.
I would echo Lyndon's sentiments that collaborations are going to be key moving forward. sharing information with the public, educating the public, doing all these research studies, vadose coring, isotope analysis, a whole host of things. The more data and information we can acquire and assemble and share with the public, I think it's going to be critical.
Yeah, I guess I would agree. I feel like as researchers, we're always like, oh, we're pretty confident that this is the reason, but working with the public, if you learn one thing, it's that people want direct answers of like, do this, this is, you should be skeptical of this. So being direct is definitely important in this line of work.
I think from a farmer's perspective, it's that I think most farmers think they're doing the best job they can, but we're always willing to learn more. And we're not trying to do anything that's negative. It's just that sometimes it's only what we know, and we don't have a better path forward of making a change because of, it might be an employment issue, it might be just the size of the farm, it might be a lot of other activities going on. But if somebody can point out something we can do better, we're willing to change as long as it makes good sense.
All right. Well, with that'll be for another panel. we can address that in probably a future time, just because of a lack of time that's available. We're officially supposed to close out for now. One, I want to thank all of our panelists. Thank you so much, and for our first panelists as well. I really appreciate your time. And so with that, we will wrap it up for today. Thank you so much. This is one of the reasons why I wanted to come back to Nebraska in the first place, was because I knew that there were complex challenges here. But kind of going back to what Dan says, I think we're practical people that want to find solutions to problems, and we can't do them in silos, and that's why we have to have conversations that are sometimes hard. It's easy to put on rose-colored glasses and try to pretend that the world is a perfect place, but that's not the truth, and we have to be able to work with a variety of different individuals to be able to solve these problems. And so I appreciate the challenges, and I appreciate our ability to address these challenges from the university perspective, because we need to make sure that we're working with the people on the ground to help lessen the load for them and make sure that when they're making these hard decisions that could potentially be financially impactful, that it's not hurting their bottom line or their bottom dollar. So with that, thank you very much. Look forward to interacting. Please feel free to come and talk to our panelists, and let's continue to try to work towards a solution around this issue. Thank you.